Alrighty, back again, or for the first time. Yeah. Do I have a camera, man? Let's see. Why not, right? Let's go ahead and jump in. I'm gonna show y'all how a real developer gets down. How a real one gets down, right? We're gonna sit here today and just talk through a particular problem. I want to show y'all. Can we duplicate this? Okay, so we're doing this real time, y'all. We're gonna go ahead and do this OBS stuff. Yeah, get it. Programming. That's just what we do. It should be filled, man. I'm coming in with something new. And you know, yeah, that's just what I do. I said that twice, man. I'm gonna get nice, yeah. So I'm sitting in my chair, yeah, you know I'm about to be over there. Yeah, they knew me. Call me BP. Had to go to the top of the sea, and you know me when I go through what I go through. And you know I be feeling real blue. Ooh, it's good. Am I going to school? Oh, okay. All right. So I'm going to stop. There you go. That's my first mixtape, y'all. Coming out December 24th. Okay. So I'm going to go ahead and add a video capture. We're going to call this Webby. And hold on. It's not a video capture. Let's delete that video capture. We need a source. So maybe it would be video capture device. Webby. Webby. There we go. Oh yeah. Hold on. There we go. It's your boy. Look at, I'm on the screen, y'all. I'm on the screen, y'all. Look at that. All right. We're cooking. Okay, so check it out, y'all. Check it out, y'all. Check it out, y'all. Okay, so I'm gonna put myself a little bit smaller. There we go. Perfect. So what we're gonna be doing today is we're gonna be doing some QLDB ledger stuff. All right. So let's go ahead and show you what I'm trying to do. This is oh man, I have so many windows that are all over the place, y'all. It's all good though. We're not worried about it. Okay, so this is the goal today. So we're gonna enlarge this. And so what I have right now is I have a particular application that I plan on deploying in the EKS cluster. And in that EK or that application, it should be able to write a transaction to a QLDB or quantum ledger. Quantum, y'all. Quantum. I mean, who even knows what quantum is? I guess there's people on YouTube. So it's supposed to write to a quantum ledger. That's all we're worried about today. So what we want to do is we want to make sure that we can go ahead and create a way to, number one, check if there's a table for transactions. Number two, be able to add a document to that table. Number three, delete the document from it. Just kidding. It's a quantum ledger. You can't delete. Yeah. So why am I doing this? Okay, so as you may know, let's just use crypto here because this is an example that all y'all know about. Crypto, we want to make sure that no one can delete anything. We want a record of everything throughout time, forever, into the future, and multi-dimensional or multi-universe thingy majigger. Okay, so that's too far. So let's go ahead and just get into it, y'all, because I'm just talking now. So we're just going to follow a simple guide. So what we're doing today is we're going to work in some Go. And let's check it out. So we already did this part. Go get. So all this is, right, prerequisites. We need to create a QLDB table. With that QLDB table, we need to go ahead and, well, excuse me, a ledger, QLDB ledger. With that ledger, we need to go ahead and create a table. in that table, we're going to put documents. So let's just go ahead and quickly map out what we want to put in these documents, because I reckon creating this stuff is going to be a bunch of copy pasta. And y'all going to love this, right? Because copy and pasting is the way. So let's go ahead and go to Fiserv API guide. You're going to see this real time. So we're going to look at the Fiserv. This is a common core banking platform. Of course, these APIs are free for everyone to use. They're on the interwebs. And what we want to do is we want to go ahead and say, okay, well, let's generate some transaction. And inside of this transaction, we're going to need to go ahead and send some data to this particular payment gateway the way it expects it. So then we look and we're like, okay, well, a credit transaction. And in this credit transaction, we have only 4 required fields. More so, 2 required. And we need the actual request type. And then we need the transaction amount. And then there's a bunch of additional metadata that we, payment method, okay, and a currency conversion. So if we're thinking about this logically, if I'm in this, let me go ahead and bring up that diagram again. Or not logically, right? I don't think logically. My brain doesn't work like that. So we could say, okay, well, we have this data center. It's going transit gateway, and there's going to be transaction data. And so we want to go ahead and record this transaction data somehow, some way, whether it fails or it doesn't fail. So we need to just record that there was an actual transaction. Now, is this how it actually happens? That's a great question. Let's read these steps. The API layer interfaces the core platform with upstream applications by creating and managing accounts. Real-time transactions come in from the payment network. So payment network handoff, transaction handoff. Because I'm curious now what that looks like. Because if I'm thinking of a payment network, okay, so me as the financial institution, it's going over some network transaction. It's been processed or not, and now it's sent to me. What type of messages do I need to store in my ledger? I think we could still think of it as how blockchain does it. So does blockchain store failed transactions? Execute smart contract fails, maybe for an exception required rules, transaction propagated to network, including the blockchain itself. Will this be a reason for this? Okay, it is included in the blockchain. The user still has to pay for the gas used to process the transaction. Needs the transactions reverted. The exception to this, of course, is if the account sending the transaction doesn't have enough ETH to cover the transaction fee and ETH cents. So we can actually assume that we're going to get at least the first transaction information, even if it is reverted. That's how it should work. And so inside of our document, we need to make sure, I guess we need to have that particular information. So is there an easy way to, there has to be an easy way to get this particular API. So this is one. Maybe we have the API reference here. Dun, 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 dun. Can we export it? It looks like there's an export. We're going to find this, y'all. We're going to find this. Okay. Oh, this is an open API standard. Beautiful. Okay. So let's just start small. Let's start small. We're getting too complicated now. We're getting way too complicated for my brain. So let's go ahead and say function to create transaction to be stored in QLDB. So let's go ahead. I guess that's what this add to DB is. So let's go ahead and say we're going to have a function create table. And actually, this should take probably a session. So it looks like, let's go ahead and take a step back for this driver and see what is actually needed. So let's go ahead, quick start. So we install the driver, import the package, initialize the driver. Okay, we installed it here, great. We imported the package. Your boy initialized the driver. So it looks like we have to create a session, and the session is going to be USC1. Now we're going to create the driver, and we're going to connect it to some ledger here. And so I have a ledger that I've already created. I'm not going to show y'all, you degenerates. I just don't want to put my information out there right now because in my brain, you all are probably too smart for your own good. So I'm going to keep it off screen, and we're just going to work with the names because, yeah, we'll just leave it like that. We'll do everything programmatically today. So then we pass it a session. Okay, great. We have a session. And I guess it looks like there's some type of callback here. Who cares what that is? Let's just not think about it for now. And we're going to defer the shutdown. So then we're going to create a table and index. So now we're going to use the driver. We're going to pass it some context. It looks like we're going to pass it some function that takes a transaction and returns some interface, so some information. Okay, great. So just an anonymous function. Inside of this function, we're going to say transaction, I execute, create table. Okay, so great. Now I think we're starting to understand what's going on here. So what we're going to do is we're just going to copy and paste this. So let's actually just do it inside of this function here. And I think we can do the defer there. We can leave it like that. I told you there's gonna be a lot of copy and pasting, y'all. You know, just bear with me. Okay, so what we're gonna do is we're gonna create index on people, and we're gonna create that index of first name. And so this is to reduce the chance of OCC conflict. I'm not sure what OCC is, but we'll figure that out as we go. So we're gonna create the table people, but we're not gonna do that. We're gonna create the table transactions. Or more specifically, maybe credit transactions might be good. Okay, great. We have the credit transactions. We're going to create an index on credit transactions. And the index that we're going to put on the credit transaction is the transaction number. And so this is going to be a unique identifier for each particular transaction. So every transaction should be unique, obviously. And we probably want to tie it to that's a good one. If we're going to tie it to something, let's go ahead and say each transaction has an amount. Let's just say amount. Let's just keep it very simple right now. So credit transactions. Great. So maybe we even, instead of putting this here, maybe we go ahead and execute, but we pass in a format string. So let's say to do parameterize table names and indexes for reuse. So that's great. We'll just put that as a to-do so we don't forget, because you know, your boy forgets a lot. Okay, so now what can we do now? Well, I think we can run it now. Let's go ahead and see. Let's check this out. Okay, we created that. People, first name, age. Okay, so fields. Indexes are required to optimize query performance to help limit. Here we go. Optimistic concurrency control conflict exceptions. What does that mean? That sounds crazy. That sounds complicated, y'all. Concurrency model and address the need of high performance online transaction processing workloads. QLDB supports SQL-like query capabilities and delivers full ACID transactions. This is atomic something. So ACID. We're gonna atomicity, consistency, isolation, and durability. All right. Let's take this because we're gonna have to probably remember that. We should know that from databases, but my brain doesn't work very well. So atomic or acid transactions. There we go. All right. So we should be able to just call this down in our main function. So let's go ahead and let's comment this out. Let's take that server away. Let's comment that out. Because the idea here is that this driver is going to be sent some requests, and in those requests are going to be transactions, and each one of those transactions should be written to a table. So now first what we want to do is check to see if the table actually exists inside of our ledger. If it exists, go ahead and call create document to go ahead and store that transaction inside that table in our ledger. Does that make sense? Great. I know it makes sense because you all are super smart people. So we're going to say add to QLDB. And what we're going to say, go run main.go. And let's see if it runs. So, all right, so it ran, but we didn't print anything. That's crazy. We should have printed something. So what we're going to do is we're actually going to go ahead and check to make sure we actually got something. I'm going to go to the transaction ledger. I'm looking, it's loading the table. Uh-oh, I got it. How do I hide this? I want to show y'all, but it's just, I don't want to show my account number here. Yeah, and it actually did do what we thought it was going to do. This is my first stream, y'all, or my first video that I'm going to put out for y'all. So I want to test some stuff. And I don't want to have to go back and edit it consistently. So I'm trying to figure out the best workflow. So here's what I'll show you. I'm going to show you a screenshot that it actually worked. There we go. Boom. I know. I'm going to get better with this over time. It's all good. But that's what it looks like right now. So we created the table and we created the indexes on the table. Now we need to just add information to the table. So now we're going to go back to our driver and we're going to insert a document. And so we're just going to go ahead and copy this code. And so you can see here, after we do that, then we're going to create a structure so that we can go ahead and do some instances of something and then easily insert it into the table without having to do all this complicated stuff, right? Like the query language that's given to us, insert into. If you're familiar with SQL, this might be familiar to you. So let's go ahead and just copy pasta here. And we all love some good copy pasta now, don't we? So I wonder what it'll do if we just leave all this. So we're going to say, right, let's copy and paste credit transactions and put this where people's at, right? And we want to insert the transaction number, right? And we'll do some random weird gobbledygook. I guess that's not a number. Maybe we call it transaction ID. That probably makes more sense. And then we'll say amount. And we'll say, let's say 100. $100. $100 million. Okay, so it's interesting. Let's go back here real quick. There's a last name here. Now, if we look at the example, I'm pretty sure we didn't specify a last name here. So now what do you see? You see us adding a field real time here that we didn't actually create on the table. And you just have to remember that this is just a document at the end of the day. So we can say transaction number, let's say transaction type, let's call it that. Let's say this is a credit transaction. And then we'll specify the amount and we'll call this 100 or 199 is cool. 199, my friend. And we'll leave it at that. So now I think we can go ahead and run this now. Let's go ahead and try it. Let's go run main.go. And it looks like we got some failures here. Okay, so now we can't recreate a table that already exists, and this is important. So now what we want to do is we want to run a check, and we want to say, what do we want to say? Maybe we want to just abstract this out, create table for now, and then we'll create some checks. But for now, let's just go ahead and abstract this out. So we're creating a new session here on the transaction ledger. Great. We have that there. Let's go ahead and when I say abstract, I'm just moving this logic somewhere else so we don't run into this error. Now, is this the best way to do it? Probably not, but that's the way we're going to do it. So bear with me. That's just how I do stuff. Okay, so we need a driver here. So let's check what this driver is. I'm trying to find the type of it because as you can see up there, we're expecting to have some type of driver. So we want to say driver type QLDB driver, I believe. So it should be a pointer to a QLDB driver.QLDB driver. And we're going to go ahead and make this a new variable here. So now it doesn't scream at us. Great. And this function is unused. That's fine. And so now we have this configuration. And so maybe we actually go as far as to create the driver globally. Let's so we don't have to continuously reuse it. So maybe we do some instantiate. Maybe let's put a to do here. To do create driver once so we don't continue to, or so we don't recreate it over and over per transaction call. That's a to do. We don't care about it right now. Let's just run this and see if it adds. All right, great. So it ran successfully. So let's go ahead and refresh our table. And let's see this transaction in action. You like that now, don't you? The transaction in action. And what I'm curious about now, let's go ahead and query it. And I'm going to go ahead and I'm going to do this table. And I wonder, maybe I do select star from, maybe this will work. I think maybe this is a traditional query language. Okay, great. So I'm going to show you what happened. Let me snip this again. This is a bad way to do it, but we'll figure this out, y'all. So let me zoom out. Actually, we'll do this. So I queried it. And as you can see, boom. That's what we have right there. And so we were able to select star from credit transactions, which is the table. So it's just standard. I mean, it's I guess it's party QL. I'm not 100% sure. I mean, that's probably some type of query language that's open source or something like that. Although MySQL or SQL is just a query language in general. So I don't know what. Let's look at party QL real quick. What is this? SQL compatible access to relational, semi-structured, and nested data. First class nested data. Data storage independence. Enables unified query access across multiple data sources and data formats by separating the syntax and semantics of the query from the underlying format of the data or the data store that is being accessed. Oh my goodness, y'all. It enables users to interact with data or without regular schema. Oh, open source. This is what I was looking for. Boom, it's open source. But I'm trying to figure out here. Okay, so it can work with DynamoDB and SQL and QLDB. One language to rule them all. And in the darkness, we shall bind. No, there's no darkness here. Okay, so all right, we learned party QL. See, y'all learned this on video now. Okay, so we were able to add that transaction. So now all we need to do at this point is make it look pretty, refactor, and do all that good stuff because we have the basic functionality that we need to go ahead and add a transaction to a table. Maybe there's some error handling. We could do some fancy stuff like this and say, hey, let's create a structure. Oh, here's a query. Okay, great. So let's go ahead and do the query. Let's do the CRUD. Create, read, update, delete. So if we wanted to go ahead and get something, let's go ahead and I wonder if we can create that transaction twice. So query the data, great. And okay, so we're gonna select first name, last name. From here, assume the result is not empty. But if it is empty, do something about it, right? We got the ion binary. Okay, so this really does assume that we actually just created that struct that I just skipped. So actually, all we want to do, we don't want any of this. Ew. We don't want none of that, y'all. You know, we don't, none of that. None of that. All we want, oh man. Here we go. This is all we want right here. This is all we want. Why isn't this? Okay, wow, it's crazy. That's really all we want. So why isn't this working now? That closes that. That closes that. And maybe like that. I think it's something like that, right? We have this. What's the error here? Oh, we didn't return something. Okay. I'm gonna return result. We want an interface. Oh man. What is the interface they're returning here? We're gonna temp a pointer to temp. And where's the result? Where are we unmarshalling? So we're saying result that get current data. Result.next. So we need to do this right here. And then we need to put the data into something. So let's go here. Let's say has next. And so now we're going into the result, it looks like. So it's going to say result.next in the transaction. And if there is something in the transaction, it looks like we're going to say this binary get current data. And then we're marshaling that data. So it's giving us something. So let's go, let's say data result equals, let's see, you say result dot get data. So now we have some bytes. Perfect. Now with these bytes, right, we have an array of bytes. I guess we need to put them in something. So now, can we put them in some empty interface? I think Go has something like that. Okay, well, now we're going to be forced to just go ahead and create this interface anyways. So we're going to say interface. No, we're going to say type credit transaction struct. And in this struct, we need a transaction number. So transaction number. And this is going to be a string because it can contain some type of string value. And this, I think, needs to be ion of type transaction number. I think it's something like that. I think that's what they did up here, right? So yeah, right here. Okay, great. So then we need to go ahead and say transaction type, and that's going to be a string. We say ion. And what do we call it down here when we added it into the table? Or we created a transaction, we called it, okay, transaction type. Just like that. Camel case, as they say. I believe it's camel case. And lastly, but not least, amount. And this is actually going to be an integer. And this is going to be ion amount. Okay, great. So now we have our credit transactions. So let's go credit transaction. And we're going to go ahead and unmarshal that into a credit. So we go ion, and I believe we already have ion imported. But we'll say this. We'll say error ion. Oh, excuse me. Error equals ion dot unmarshal. And we need to unmarshal data results into an instance of, oh, right, we didn't create the actual transaction. So transaction equals, we need a transaction. Do we do new? We can do new. I haven't used Go in forever. Okay, so new credit transaction. Nice. So now we're gonna unmarshal the data result into the transaction. And then we're gonna return a pointer to the transaction. Oops. A pointer to the transaction and the error. I believe that's what it wants us to do. A returned person. What is this? So we're storing this. If error is not equal to nil, panic. Okay, so this is checking if it's wrong or not. But we don't want to do that because we're lazy. So I think we're good. So now we just want to go ahead and we want to console. No, there's no console.log. It's fmt.printf. Or let's go print line. This is a person. I think we could do it here, right? What is this throwing? Why is this yelling at me? Okay. Great. Can we do this? I think we can't. Well, let's do printf. And I think we could say something like this is %v. Is it %v? Maybe it's, yeah, let's pass the value. Maybe it's like that. And then we want to pass in p like that. Right? I think it's something like this. If error is not equal to nil, let's catch the error, panic, and panic with the error. All right, I think we're good now. All right, the moment of truth. Oh, people. Okay, so I didn't change this. I used the boilerplate. That's crazy, y'all. That's crazy. See, I wasn't paying attention here. So transaction number, right? And transaction type and amount from what is this called? This is called the credit transactions where where amount is greater than 10. I think that'll work. So we're gonna get all the transactions where the amount is greater than 10. And okay, okay, we got something, y'all. We got something here. This is, and then we got %v, which is p. So maybe we can break this out, and we say p dot. I guess we need to set. Nah, forget it. We'll just say p. Forget it. We need to make it so that it's actually the variable we expect it to be. But that's fine. It's just an interface for now. And as you can see, we actually got the data out. And what I'm curious to see is, I'm gonna run it one more time and see if it created another. So there's 3 transactions and these are all distinct. This is interesting. This is actually very interesting. So I selected all the trends. So let me show you all. They're all these different trends. Okay, so let's go ahead and don't mind me highlighted. I'm lazy right now. Look at that. So 3 separate transactions here. It pulled 3 documents. So that's very interesting. It's fascinating. Okay. Let's go ahead and I guess update the document. Set age where first name equals this. So we can update the document to probably successful. And I'm wondering, okay, well, let's just go ahead and do the update now. So let's say update the document, right? And all we done is we just copy and paste it, right? So, which is great. We love copy pasta all day, every day until Sunday. So we should have created, we probably should have done this particular step right here and called it a transaction. So we should have said up here, let's say not a person, but a T new. There we go. There we go. And we call this a credit transaction. All right. And in this credit transaction, we have this particular transaction number, right? Great. And maybe, no, see now I'm doing too much. I had to go up there. I'm trying to do too much copy pasting. So this is the type and this is the amount. So now we have T new here. And so now we want to go ahead and update it. And so what we're going to do is we're going to update the amount of the transaction, which is interesting that you can do this. So we're going to say T new dot amount plus equals 100. Okay. Now we've updated the amount inside of that transaction. And now we want to go ahead and update. So let's go ahead and take this particular part. And let's go ahead and do this and just format it a bit, make it look nice. We don't need that anymore. So we want to say where credit transaction, well, where T new dot amount, right? And T new dot what is it? transaction number. And so now we want to update the credit transactions. Credit transactions. And we want to set the amount, right? So now we're passing in the amount and we're saying where transaction number, right, equals to these numbers. And so now we're in place of those two question marks, we're going to put the actual transaction amount that we're updating and the actual transaction number we want to update. And so now that should be enough. So let's go ahead and run it. All right, so let's check this out. Let's see what it did actually. Now we have transactions where the amount is, or the actual number is the same. So let's see how it handles this. I'm actually very much curious. And let's go from credit transactions. So we're selecting everything from the credit transactions. Don't mind me, y'all. I'm just running the query right now. So I'm getting all the datas. Okay, so I'm curious. It updated all of them. It updated every single one of them. There we go. So if you have duplicates, it's going to store every single document and it's actually going to go through and update every single document. So there you go. I added 100 to the actual transaction amount and it actually updated every single one. Fascinating. So you probably want to have to catch that somehow. And there's probably something in this architecture that does that. Okay, so now we did that. What's the final step in this? The final step is query the updated document. And so it's going to select where the first name and it's saying, okay, result, get the data. We're going to unmarshal the data. We're going to append this data to people where we created, there's going to be some array of people right here. So array of persons, or that'd be array of transactions. And so we append that there. And then we go ahead and do a check here. And then we drop the table if we wanted to drop it. So that's pretty much it, actually. That is the first go around on create or working with the Go driver for QLDB. I think we learned a good amount here. And now we just need to continue to extend it to make those necessary changes to make this more usable for people. For people, meaning me, right? And YouTube on the YouTubes. So anyways, I think that's going to go ahead. That's going to be it for this particular video. I think I need to cut out a small part at the beginning, but hey, it is what it is. I hope y'all enjoyed what y'all saw. I hope you learned something, and go ahead and try this out for yourself. I mean, it's just go ahead and play around with QLDB. If not, just look out for my next video. I'll holler at y'all. Peace.